Welcome to the Other Tools tutorial, Accuracy, Troubleshooting, and Advanced Topics. In this tutorial, we describe troubleshooting a camera setup, troubleshooting referencing, the Edge tool, the Cylinder tool, adding photographs to a project, using multiple cameras, the Curves from Points tool, and orthophoto export. We start this segment by opening the project called buildingwrongcam.pmr with photos 1 and 2 opened. The object being modeled is a building. So far we have marked some points and lines and oriented the photos. Our goal is to create a detailed model of the facade of the building and generate an orthophoto. This building is quite complex for a facade. It contains many elements, including curved surfaces, inset areas, and cylindrical sections. This project will be used to demonstrate a number of tools and features that will help in proper modeling of the building. First, we will do some accuracy and troubleshooting work. The steps described here can be used on most photo model projects to improve the results. When troubleshooting, we first determine what is wrong and then we fix it. We take a look at the model in the 3D viewer. We open a 3D viewer window with points and lines on, click OK, and maximize. We can see that these lines do not look perpendicular to these horizontal lines. These inset areas are clearly not perpendicular to the front of the building. These clues indicate there is something wrong with this project. Our first step is to look at the information Photo Modeler can provide for us. We click the Project Status Report Tree button on the toolbar. This brings up the Project Status Report, which we have already seen in an earlier tutorial. If we look at the Problems and Suggestions area, it says there are 2 problems found. We expand the tree to look at the problem descriptions. The first problem indicated is that the camera we are using is not calibrated. In many cases, you can get good results with an approximate camera. In this case, it is causing a problem. The second problem is that the project's largest point residual is very large. A point residual is the difference between where the program thinks the point should be and where it is actually marked on a photograph. The residual here is over 17 pixels, which is quite large and usually only found in projects where a problem exists. We close the status report. We select Project Cameras to view the Cameras dialog. Our current project camera called EOS 3040 Approx is listed. We click Modify to look at our approximate camera parameters. It shows that we have no lens distortion parameters, and the values with no decimal places for the focal length, format size, and principal point are indicators that the camera is not set up very accurately. This camera description was set up using a quick project setup. A project using an approximate camera may work well. Even a camera not set up that well can sometimes do okay. The project can process and orient successfully, but the accuracy will be poor, and in this case the resulting 3D model is warped and incorrect. In some projects with incorrectly set up cameras, the project may not process and orient at all. To fix this project, more accurate camera parameters are needed. The camera parameters can be modified, or a new camera can be added at any time. In this case, we will load the correct camera. We click the Load button and select EOS3040.cam from the Other Tools folder. It is now listed in the Project Cameras list as EOS Olympus 3040 Wide. This is an Olympus 3040 digital camera calibrated at its wide-angle zoom setting. It is loaded into the project but is not yet associated with any of the 3 photos. What we have to do is change the photo settings so the photos use the EOS Olympus 3040 Wide camera instead of the EOS 3040 Approx camera. We open a photo table from the toolbar. We choose the camera configuration from the drop-down list. We can see the name of the camera that is associated with the photos. We select all the photos by selecting the first row, pressing Shift, and selecting the last row. We click the Properties button to bring up the Photo Properties dialog. We click the Cameras drop-down list and select the new camera. This tells Photo Modeler that all the selected photos will now use these camera parameters when processing the project. We click OK. We see in the photo table that each of the 3 photos now lists the EOS Olympus 3040 Wide as its camera. We close the photo table. In order for the new parameters to be used properly, we must reprocess the project. We click Process from the toolbar and click Process. The error bars show a high initial error. This is where the program is compensating for the previously incorrect camera parameters. As it processes, the error is reduced and the final error number is quite low. We click the Show Report button for an update. There are no project problems listed now. This is because the new camera description is a calibrated camera, and the resulting project did not have large residuals. There is one comment listed in the problems related to the most recent processing section. It tells us there were more than 10 iterations in the processing. We know this is because it was trying to correct for the previously incorrect camera parameters. We click Close and OK to close the dialogues. We will recheck the results in the 3D viewer. We click Reset on the Open 3D Viewer window to get a top-down view of the model. The side parts are all now correctly lined up. We rotate for a front view, and we can see that the lines are much straighter now, and the project is much more square and perpendicular. The improved project results show the importance of using a calibrated camera. In this segment, we will troubleshoot problems that arise from referencing errors. We start with the buildingref-errors.pmr project from the Other Tools folder. We open a 3D viewer with points and lines, click OK, and maximize. We review the project from a straight-on view. These lines across the building look relatively square, but if we look at this section off to the side, it does not look correct. They should be rectangular, but they appear skewed. There is something clearly wrong with this section. If we process the project, we can see that the final error is higher than we would expect, especially in a project that uses a calibrated camera. We will now determine what is wrong. First, we click the Show Report button to bring up the project status report. There's one problem listed. It tells us the largest point residual error is almost 55 pixels. This is a very large error that we wouldn't want to see in any project. It indicates a serious problem that needs to be fixed. Since we are using a calibrated camera, we can conclude that the problem is not due to the camera. We then look for a problem associated with reference points. We close the dialogues, then open a point table, and choose the quality configuration. We then click on Largest Residual Column heading to sort by largest residual. The top row in the list shows the point with a 55 pixel residual error. To investigate what is wrong with the point, we select the row, right-click, and choose Open Photos Showing Selected. This will open all the photographs that this point is marked and referenced on. Photos 1 and 3 open, and the selected point is highlighted in red. We click Zoom Photo Area and zoom in on the section where the point is marked. We study the points to see what is wrong. We can see that although there are reference points, but they are actually marked in different positions. We may have got confused when matching up the points, as this point is marked on this lower slanted section, and this second point is marked on the higher slanted section. We can correct this referencing error. First, we will unreference the point on the lower slant in Photo 1 by selecting, right-clicking, and choosing Unreference Selected. We then unreference the point on the top slant. We also clean up some of the lines that have been connected to the incorrectly referenced points. Next, we will properly reference these points. Using the Shift key and Select tool, we select the two matching points on the lower slant section and click Quick Reference. We repeat for the 2 points on the top section. We then use the Line tool to connect the points properly. We reopen the 3D viewer window and see that the model has improved. When a large referencing error has been corrected, it is a good idea to reprocess the project, as those errors may have had a negative effect on the rest of the model. We reprocess and receive a much better error bar and final error number. We view the status report and there are no problems reported. We close the dialogues. We reopen the point table window and look at the highest point residual. The very large errors are greatly reduced, but we still have this point here with almost a 3-pixel residual. In some cases, this error would be acceptable, but it is high enough that we want to investigate. Again, we right-click and choose Open Photos Showing Selected. All 3 photos open with a highlighted point. We use Zoom Photo Area to zoom in on all 3 photos. The point is referenced correctly, but if we study the positions of the points, we can see that the point in photo 1 is not marked in the same spot as it is on the other 2 photos. In photo 1, the point is mistakenly marked in the bottom part of this facade section. This is a marking error. If we select the point on photo 1, we can see the residual error in the status bar. We can fix this point by selecting and dragging it into the proper position. Notice on the status bar that the residual error updates as we move the point. We reopen our point table window, and our largest residual is now just over 1 pixel, down from almost 3 pixels. We have shown how to troubleshoot referencing and marking errors by first determining there is a problem, then finding the source of the problem, and making the correct adjustments to fix them and improve the project. In this segment, we will work with edges. We start with a project called buildingstart.pmr from the Other Tools folder. The 3 photos are opened and tiled. To make things a bit faster for us, we will first add the Edges tool to the toolbar. We right-click over the toolbar and choose Customize. We click Commands, Marking, and choose the Edges tool. We drag over into this position on the toolbar, then close the Customize dialog. We open a 3D viewer with points, lines, edges, surfaces, and cylinders, and the shaded option chosen. We click OK and select Window Tile. We use the 3D viewer controls to view the results of the facade drawing so far. There are a number of sections that do not have connecting lines. This is due to photographs being taken from ground positions. We are unable to see the points at the bottom of these areas, and therefore we cannot mark them. This is a common issue when you want to mark points on an object, but you cannot get the right angles to photograph them, or they are obstructed by some other object. In photos 1 and 3, we use Zoom Photo Area for a closer look at the slanted sections. On this patio area, we can see the top and bottom point on photo 1, but not in photo 3. For the far corner, we cannot see the bottom point on either photo. This makes it impossible to model using the regular point and line tools. The Edge tool is designed to help in these scenarios. We click the Edge tool from the toolbar, and the cursor changes to Edge mode. We move the cursor over to this edge of the patio, click once at the top and once at the bottom, and an edge is created. The edge mark looks different from a line mark in that its endpoints are small circles, and its line has a slightly different pattern. An edge is not a line connected by 2 points. An edge is a single entity with 2 endpoints. The importance of an edge does not lie in where its start and end points are, but where the position of the edge line is. The start and end point positions of matching edges across photos do not need to match. You can estimate the endpoints of edges in order to do the modeling you need. A short edge can be referenced to a long edge as long as the lines match up. The final length of the edge is determined by the longest edge that is marked in the photos. We mark the rest of the edges in the patio area of both photos. Again, we can't see the endpoints, so we estimate its end position. The edge's endpoints do not snap to regular 3D points. The position of the edge endpoints must be moved close to the corner so the model will look correct. We mark this point so it closely matches the corner marked by the regular point. We use Alt-Zoom to adjust the edges. Again, the endpoints are not so important as marking the edge line in the correct position. Edges must be referenced across photos before they become 3D. We use Select and Shift to select these edges, then click the Quick Reference tool. Since the photos are already oriented, the edges will automatically compute. In the 3D viewer, we had already turned edges on, and we can see that edge appears over here. We reference the second edge using Quick Reference, and the edge appears in the 3D viewer. One of the keys to making edges calculate properly is having the proper photograph angles. The edge must appear on at least 2 photographs, but can be on 3 or more. The photographs must be rotated around the edge. For example, in photo 3, we have a straight-on view of the building and the vertical edge. In photo 1, the photo angle is rotated to the right, and we have a rotated view of the edge. If we were marking a horizontal edge, then we would have to get photographs from different heights. These requirements also apply when doing cylinders, which we will look at in the next segment. If we select the edge, the angle between the photos is shown in the status bar. We have an angle of 33 degrees. If the angle between edges falls below 20 degrees, the accuracy of the edge will drop. Similar to most referenced 3D objects in PhotoModeler, the closer the angle is to 90 degrees for the photos, the better the result will be. Edges can have surfaces attached to them as well. We select Surface Boundary Patch Mode, then select 2 edges. We right-click and choose Finish Surface. We can now see the surface in the 3D viewer connected to the 2 edges. We will add more surfaces to this model later in this tutorial. We have demonstrated how the Edge tool is useful for modeling features that cannot be modeled using normal points and lines. In this segment, we will demonstrate the Cylinder tool. We use the BuildStartCyl.pmr project with the 3 photos open. We also have a 3D viewer open with lines, edges, cylinders, and surfaces turned on. This building has some interesting elements in its architectural design. In this corner, there are a number of large cylindrical structures that are an important part of the facade. We zoom in on these sections for a close view. To mark these poles, we use the Cylinder tool. We click the Cylinder tool from the toolbar, and our cursor changes to Show Cylinder mode. The Cylinder tool is similar to the Edge tool in that it is used to mark along the edges of the cylinder object, and the endpoints are not important. With the Cylinder tool, we mark the 2 visible edges of the cylinder. We will use photos 1 and 2, which capture the area in question and have good angle rotation around the poles. On photo 1, mark a point at the top part of the cylinder along the left edge. Then move the cursor and mark a point towards the bottom along the same edge. We mark the point at the bottom as far as we can see. This finishes the one edge of the cylinder. We then move over to the right edge and mark 2 more points. When finished, the cylinder mark appears with 2 edges and a joining line in the middle. We repeat the steps and mark the cylinder in photo 2. Again, the endpoints do not need to match, but the cylinder edges should be marked along the same position. We use the Alt-Zoom feature to adjust the cylinder positions. If you have difficulty seeing the edges in the photograph, Image Enhance can be used to adjust contrast, brightness, and gamma so the features are more visible. Next, we will reference the cylinders. We use Select and Shift to select them, then click Quick Reference. The cylinder appears in the 3D viewer with a shaded surface. We use the 3D viewer controls to review the cylinder. Next, we will mark this smaller cylinder over here on photos 1 and 2. We mark them in both photos, then zoom in to adjust their positions. You can see that as we drag a point, the cylinder mark temporarily disappears, so we can get a better view of the edge. We select the cylinders and quick reference them. The new cylinder appears in the 3D viewer. When you select a cylinder, some information about it is displayed in the status bar. We see its ID number, its diameter, its length. This is the center line vector. This tells us that the cylinder is almost straight up and down in the z-axis. This is the angle between the marked cylinders. Here it is 61.6 degrees, which is a good strong angle. We get an estimate of the cylinder error. This is similar to a residual. It provides a good rating at 1.3%. A rating of 2% or below reflects a strong result. A rating around 3% is acceptable and might improve if referenced to additional photos with strong angles. The status bar also displays the material, layer, and which photos the cylinder appears on. We have now learned how to use the cylinder tool. This tool is useful for creating more complete models. In this segment, we will show how to add additional photographs to the project. First, we click Window, Close All to close all the photos. We then right-click over the photo chips in the sidebar and choose Add Remove Photographs. The dialog box opens and we select photos B4 and B5 from the project directory, import them, and click OK. We get a warning message called Images Do Not Match. This warning can show up in two cases. One is if the focal length that is stored in the JPEG EXIF file created by the digital camera does not match the focal length set in your project camera. This may happen if you change the camera zoom settings. The second case is where the new photos do not match the image size parameters defined by a current project camera. It tells us that using these photos will result in poor accuracy. The image size defined by our camera is 2048 by 1536, while the new images have 2560 by 1920. PhotoModeler assumes that these photos were taken with a different camera. We close the warning dialog box. We receive another message asking us to confirm that we understand if we continue using these new photos with the current camera, the project will not produce good results. We click OK. To fix this, we must assign these two photos the proper camera. PhotoModeler can easily handle different cameras in the same project. We open a photo table and choose the camera's configuration. All 5 cameras have been set up with the default project camera, EOS Olympus 3040 wide. We know that the two new photos were taken using a different camera. We select the two photos and click Properties to bring up the Photo Properties dialog. We click Cameras, then Load, and point our mouse over the .cam file called EOS 5050. This refers to the newer Olympus 5050 digital camera model. We click Open, and the camera is loaded into the project. We close the Cameras dialog. We then select the EOS 5050 camera from the drop-down list. This assigns this camera to the two selected photos, photos 4 and 5. This is how we change which cameras are assigned to particular photographs. We click OK to close the Photo Properties dialog. In the photo table, it now shows that photos 1, 2, and 3 have the EOS 3040 camera assigned to them, and photos 4 and 5 are using the EOS 5050 camera. We close the photo table. We move ahead to the Building New Photos project file located in the Other Tools folder. This version of the project has the two new photos in the project already oriented and with marked and reference points. In Photo 4, we see a number of marked points. They have been referenced to points on Photo 2, which were part of the original orientation. You need at least 6 points on the new photograph to be referenced to the other photographs for it to process and orient correctly. In Photo 5, a number of points are shared with photos 2 and 3. For example, if we select this point and look at the status bar, We can see it also appears on photos 2 and 3, and this point also appears on photos 2 and 4. We referenced enough points to orient the photo included as part of the project. We open a 3D viewer and turn on points, lines, edges, and camera station, and click OK. We maximize and view the model. We review the camera station positions. These are the 3 original camera stations that were used to create the initial model. These 2 cameras here are the new photos taken with the EOS 5050 camera. They show close-up shots of this section used to add detail to the lobby section of the building. In this segment, we add a new type of curve and surface to the project. In the 3D viewer options, we turn on lines, edges, surfaces with the shaded option, curves, and turn off camera stations. We review the model of our facade so far. We minimize the 3D viewer and look at photos 4 and 5. These points along the top of the glass window in the lobby have been marked and referenced across these 2 photos. We want to create a curve which will be used to create a curved surface using a surface feature called Sweep. We will create the curve using the Curve from Points feature. We zoom in on photo 5 for a closer look. We then select Marking Curve from Points, and the cursor changes to the Curve from Points mode. We then select the points along the glass in order. We can see the points being marked in photo 4 as well. When we are finished, we right-click and choose End Curve. Much like surfaces, Curve from Points are 3D objects only and do not appear on photographs. To view this type of curve, we click the Projected tab and turn on Curves. We can now see the projected curve line connecting the points. We reopen our 3D viewer window, maximize, and use the controls to get a view of the curve. We can see from this top view the curve we created. Next, we want to add a curved surface using a sweep. We select Surface, Sweep Mode, and our cursor mode changes. A sweep surface takes a rail curve and a section curve, and sweeps the section curve along the rail curve. We select this edge, and then the curve, and the surface is created. We review the model in the 3D viewer, and we can see the new curved surface created in sweep mode. This helps us properly model this section of the facade. In this last segment, we will export the model as an orthographic photo. We start with buildingdone.pmr located in the Other Tools folder. This project has all our marking, referencing, and surfacing work completed. We open a 3D viewer with lines, edges, and curves turned on, which gives us a view of the outline of the building. We see our marked lines, edges, and curves in the model. We go back to Options and turn on Surfaces and Cylinders. We view the detailed coverage we have of the facade. Next, we turn off points, lines, and edges, leave surfaces and cylinders on, and turn on Fast Textures. We view the current textured model. Most of the surfaces are using the default material, while some of the other surfaces have been assigned to grab textures from particular photos. The textures have some distortion, but that is to be expected when using fast textures and photos that were not taken straight on. We could correct this by using the Quality Textures option, but we will leave it for now. Here we want to create an orthographic photograph of the facade. This is the end goal of this building project. An orthographic photograph is very much like this current view, a straight-on view of the building, but it is done at very high precision and at high resolution. An orthographic photograph, or orthophoto for short, is a parallel projection onto a plane of the model data with photographic information. It can be used as a type of drawing when printed out because it is to scale and you can do measurements on it. To set up for this orthophoto creation, we first set up the model with the correct photo textures. We then select File, Export Orthophoto, which brings up the Export Orthophoto dialog. There are a number of options in this dialog. The first option asks where we want the photographic data to come from. The first choice is from all photo-textured surfaces. This is the best choice in most cases. It creates an orthophoto that looks similar to the view seen in the 3D viewer. The other choice is a rectangle on photo, which allows you to select a single rectangular area on a particular photograph. The actual area is defined by 3 object points. The point IDs are entered here. This is useful for simple planar objects and for doing rectified photographs. The overscan controls the extra amount of photograph to create as a border. We enter an overscan of 2%. Then we have to choose the projection plane where the orthophoto is going to be projected onto. If you have set up a scale and rotate, which we have in this project, then one of these 6 choices is best. In our case, the front XZ plane is the plane that we want for our projection. You can also use the 3-point option and pick 3 arbitrary object points on your object, and the plane will be defined by the plane between those 3 points. You can define a rotation, but in this case we will use the default. We click the Update Preview button, and it quickly generates a very low resolution preview of the orthophoto. This allows us to confirm that we have the correct plane defined. We can see that we have a front view of the building with a little bit of overscan. Next, we want to pick the output image size. The first choice is to make it a certain number of pixels. The second and third choices are generally more useful as the orthophoto is exported at a fixed and known scale. We can set it so a certain number of pixels, in this case 100, are exported per meter or foot, etc. This enables us to count pixels on the orthophoto and do a true measurement on the building. Print scale is much like image scale, but is done more in terms of printed drawing scale. So here we have a scale of 1 to 10 drawing at 100 pixels per inch. We choose the image scale option and use the default of 100 pixels per meter of real object space. This means 1 pixel on the image will equal 1 centimeter of real measurement. We click Export, and a dialog appears, allowing us to choose an image type to export. We will use the TIFF format. We give it a unique name and click Save. PhotoModeler then remaps the pixels so they are accurately placed given the camera lens distortion, the position of the surface, and the solved camera stations. The more accurate the project is, the better your orthophoto will turn out. We get a message telling us the orthophoto was successfully exported. We close the dialog. Next, we will open the orthophoto in an imaging program. This is the orthophoto extracted from our project. 1 pixel in this image will equal 1 centimeter on the actual building. This photo can be used for actual representation and measurement. This concludes the tutorial on accuracy troubleshooting and other tools. We have worked through the topics of troubleshooting cameras, troubleshooting referencing, the edge tool, the cylinder tool, adding photographs, using multiple cameras, curves from points, and orthophoto export.